Okay, good morning, everyone. Welcome to the breakout session, room number 2, day 1, for the Manitoba Protein Research Strategy Symposium. My name is Michael Jansen, and I'm a Research Development Manager at the University of Manitoba at the Richardson Center for Food Technology and Research. So we have 6 speakers today, all students at the University of Manitoba. Each speaker will be given 5 to 6 minutes to present, with 4 to 5 minutes for question and answer. So each speaker is allocated 10 minutes. And at the conclusion of the session at around 11:50, there will be a People's Choice Award after the last presentation, where there will be voting for the best presentation. Our first speaker starts at 10:50, so we have a few minutes before we can start. And during that time, I'm just going to do some downloading of slides just sent to me. Just give me one more minute. Okay, so the 2 speakers that sent me slides, I now have them with on my file. Okay, I think we can get started. We're a little early, but that's okay. So the first speaker of the session is Martin Mergenthaler. He is an undergraduate student at the University of Manitoba, and the title of the talk is Exploring Physical Modification Methods for Improving the Techno-Functional Properties of Canola Meal Protein.
All right, so I'm just gonna share my screen. So I hope you all can see my slides. And yeah, then I would say
Yes,
let's start this. All right. So hello everyone, and welcome to my presentation with the title Exploring Physical Modification Methods for Techno-Functional Properties of Canola Meal Protein. Quick introduction of me. My name is Martin Mergenthaler. I'm an undergraduate bachelor student, and I study biochemistry in my home country, Germany, at the University of Tübingen. I'm a MyTex intern at the Richardson Center for Functional Food and Nutraceuticals at the University of Manitoba in Winnipeg. And I do my research in a research group of Dr. Bandera for a time period of 12 weeks. So let me introduce my project to you. Canola is one of the most widely grown crops in Canada, as it is used for oil production and is a good source of protein. However, the properties of the canola protein are not yet good enough to be used in the industry in large stems. Here I refer to properties such as stability, surface hydrophobicity, solubility, etc. To change this, we want to modify and improve the canola protein. There are different types of modification you can use for that, such as chemical, physical, or biochemical methods. For this project, we have chosen physical methods. Based on this, the title of my research project is Improving the Techno-Functional Properties of Canola Meal Protein via Physical Modification Methods. So to sum up, my project focuses on improving the functional properties of the canola protein using physical methods such as, in our case, heat, sonification, and a combination of these two. This will allow the protein to be better used in the industry and to be considered as a sustainable protein source. As I mentioned earlier, we will use heat and sonification to modify the protein. We have decided to use these methods because they're environment friendly and sustainable, so there will be no hazard of the planet or environment. Furthermore, you don't add anything to the protein, so the protein stays kind of clean in comparison if one would use chemicals for modification. The purpose of this project is that these proteins can be used in the food industry, so no substances are going to be used which could be hazardous for humans. For the modification, we are going to prepare a solution, 2% weight per volume out of protein and distilled water. For the sonification, we will use a frequency of 20 kilohertz, 90% amplitude for 2 minutes, and for the heating modification water bath for 50 minutes is 85 degrees. The parameters are the same for the combination. After modification, the samples are freeze-dried and then analyzed. During the modification, disulfide and hydrogen bonds are going to break inside the protein due to heat and vibration. So in order of that, parts of the quaternary, ternary, and secondary structure will be destroyed and the protein has to refold. In order of that, some new techno-functional properties can be made. So since I'm still at the beginning of the project or no data has been collected yet, these are only results we will assume. So we suspect that the properties of the canola protein will improve since CGNC applied the same modification methods as we did to pea protein isolates in one of his papers and obtained corresponding improvements. Therefore, we expect improvements in protein solubility, emulsification properties, foaming capacity and stability, and surface hydrophobicity. Because of the modification methods we use, nothing can be specifically changed, so we don't know how the protein will exactly change. It could get improved techno-functional properties, but just as well, they could get worse. So what are the benefits of this project? Canola protein has a balanced amino acid profile, high neutral values, and a balanced flavor, which makes it an ideal substitute for like meat and dairy products. As the market for plant-based food alternatives is booming, not only in Canada, but all over the world, there's a great economic benefit for Manitoba and due to export also to Canada. Canola oil is very common, so there's a lot of waste after oil extraction. And to reduce the waste and increase sustainability, we use remaining defetted canola meal and modified proteins, which you can extract from it in order for better use in the food industry. Since no chemicals were used for the modification, there's no danger of pollution of the environment. In addition, there's no need for extensive purification or neutralization processes, which is a great advantage. And furthermore, eating less meat or consuming less animal-based protein and more plant-based protein instead is a step in the right direction to counteract climate change and ensure sustainability on Earth. So this is the end of my presentation. Thank you so much for your attention. And if you have questions, don't hesitate to ask me.
All right. Okay. Thank you, Martin, for that presentation. Are there any questions from the audience? Maybe one question I had is, you may have mentioned this in the talk, but once the techno-functionality processes have been performed, and so then you have your modified canola meal, what tests will you perform to determine how the properties of the canola meal have changed?
Yeah, so we want to do some STS pages and some SEM, and also try to analyze the solubility. So we're like trying to solubilize the protein at different pHs, for example, and then just divide this this number by the all amount of proteins in the samples. And we're going to try to do the surface hydrophobicity with some modification lab member of mine invented. And also the emulsification properties and foaming capacities. Yeah. So these are the first analysis we want to do.
Okay. And if anyone does have a question, please let me know. Maybe another question. So you've then performed these tests, and you've identified a canola meal protein that has a favorable profile. What applications would follow from? Do you have any ideas of what potential applications you could do after some of those tests have been performed?
No, to be honest, no. I don't know anything about it. So yes.
Okay.
Sorry about that.
Yeah, no, that's okay. Well, it's interesting line of research in Saskatchewan. There's a very large expansion of canola meal production. So in the next few years, there's going to be a significant increase in canola meal in Canada. And so we need to find new applications and new research to bring value to that product. Any other questions for Martin? No. Okay. If not, oh, we have a question from the audience. I guess the question is maybe discussed earlier, but what type of products are you envisioning to use this product? So after your treatment, you've identified some novel properties. Any end use products? Is it in the food industry or packaging?
Yeah, so we would assume there's the food industry. Yeah, so like for like dairy products and meat alternatives. Yeah.
Okay. Okay. Wonderful. Okay. Okay. Very good. I think we'll move on to. Thank you very much, Martin, for the talk. We will move on to the next speaker, and it is Jenny Bouchard, a master's student at the University of Manitoba, and her talk is Beyond Beta-Glucan, the Health Effects of Oat Protein. And you just need to unmute.
Hello, everyone. Can you hear me?
Yes, we can.
Excellent. All right. Hold on. Just let me move something out of the way. Perfect. All right. So hello, everyone. My name is Jenny Bouchard. I'm really happy to be here. And before I tell you about my project, I'd like to tell you a little bit about myself. So I have a bachelor's degree from U of St. Boniface in biochemistry and microbiology. And currently I'm a second-year master's student studying food science at the U of M with an emphasis in bioactive components in mainly whole grains and how they interact with the metabolism to attenuate chronic disease and maintain good health. So my supervisors are Cijo Joseph and Manika Malagoda, and I'm doing my studies at CCARM at the St. Boniface Research Center in Thomas Neddy-Cadden's lab. And I'm on track to graduate in December. So far, it's been such an awesome journey and it's just been great. So, and super quickly, I'm always looking to make new connections. So if you wish, please reach out to me on LinkedIn after this if you would like. Okay, so I'd like to introduce my project. It's called Beyond Beta-Glucan, Investigating the Health Benefits of Oat Protein. I'd like to quickly thank the Prairie Oat Growers Association for funding this project. So to start off, as you know, oats are a staple food with many health benefits. There are many bioactive components in oats that are shown to support good health. Among them, we have beta-glucan, which is a soluble fiber that has been shown to lower cholesterol and manage blood sugar. This is supported by a large body of research, and there are health claims supporting this all over the world. We also have avena-anthromides. They are phenolic compounds with antioxidant and anti-itch effects. We often take advantage of these compounds with colloidal oatmeal. And finally, we can recognize oats as a very good source of high quality plant protein. So oats contain around 11 to 15% protein and have a better amino acid profile than other cereal grains. So this includes a higher amount of limiting amino acids such as lysine. However, there's a big gap in the literature pertaining to the health benefits and the disease-fighting effects that oat protein has to offer. So this brings me to my research project. We wanted to investigate whether oat protein, separate from beta-glucan, can lower cholesterol and attenuate other markers of metabolic syndrome, such as high blood pressure and hyperglycemia. So the objectives of our study were to first extract the oat protein from Canadian grown oats and incorporate it into a new experimental diet. Then with a high fat, high sugar diet animal model. We want to evaluate the effect of oat protein supplementation against hypercholesteremia and markers of metabolic syndrome. And lastly, we would like to elucidate the biochemical mechanisms by which oat protein lowers the levels of blood cholesterol and glucose in this model. So on to my methods here. So first, we did extract the protein fraction from Canadian grown oats. We used a wet extraction method. It was incorporated into our new experimental animal diet. Then our animal study had 3 groups of Worcester rats. So first, we had a control group with a normal diet with casein as the protein source. Then the next group had a high fat, high sucrose diet, also with casein. And this is to induce metabolic syndrome in the rats. And the last group also had a high fat, high sucrose diet, but this time we substituted our casein with our wonderful oat protein. So the feeding trial lasted for 16 weeks. During this time, we assessed blood pressure, the structure and function of the heart with echocardiography. We also ran an oral glucose tolerance test. Currently, we are analyzing the serum lipid panel to determine the hypocholesteremic properties of oats and oat protein. We're also using ELISA kits to attempt to elucidate the mechanisms in which oat protein alters lipid and cholesterol metabolism. So, though the analysis is still in progress for our study, we do anticipate that oat protein diet will improve the lipid profile of the rats, including cholesterol or lowering cholesterol and the markers of cholesterol metabolism, improve the glucose metabolism, such as lowering blood sugar and postprandial glycemic response, and to improve the structure and the function of the heart. So our study does contribute to the protein ecosystem in a few ways. So first, establishing the health and disease fighting properties of oat protein will benefit many. It will enhance the consumer perception on oats as a whole healthy food, as most research on oats is focused on beta-glucan. Demonstrating the cholesterol and glycemic lowering properties of oat protein will make oats a protein source of choice for consumers, especially those affected with diabetes and hypercholesteremia. And finally, as Canada is one of the leading exporters of oats in the world, it will benefit our oat producers and farmers by increasing the marketability of oats as a sustainable plant-based protein and allow them to stay relevant and competitive in our health food markets. So thank you very much to everyone that listened. If we have some questions, please let me know. Thank you.
Okay. Well, thank you very much, Jenny.
Thank you.
Maybe I'll start off in terms of the background for this project. Going into it, did you is there supporting data suggesting the health benefits of oats in this particular disease indication?
So in particular, oat protein, there are 2 studies, Chinese studies. They evaluated the efficacy of Chinese oat protein in hypercholesteremic hamsters. And they reported that oat protein can effectively reduce LDL cholesterol and increase HDL cholesterol, which suggests that oat protein can potentially be a component in cardiovascular disease reduction. Additionally, they had another study where they compared the effects of the oat beta-glucan against the oat protein, and oat protein was more effective to reduce the cholesterol, and even then together, oat beta-glucan and the oat protein provided a synergistic effect together. So yeah, so we wanted to evaluate Canadian oats and also in a metabolic syndrome model, as many of the disease markers such as high blood sugar, hyperglycemia, and high cholesterol are things that Canadians deal with on a frequent basis. And since we are such a good oat producer and exporter, this would add a lot of, good effects.
Okay. Thank you. Questions for the audience? Please feel free to put them in the chat box. Maybe okay, a question from Claudia. Do you know how much oats that we need to eat to obtain health benefits? And which one of the health benefits is well documented?
So most of the research is focused on beta-glucan. So There's actually Canadian health claims, there's tons of European health claims that it's able to effectively reduce high cholesterol and like lower blood sugar. And I believe it's 3 grams per day of beta glucan, which is essentially a serving size of a bowl of oatmeal. So it's not like we need to, consume tons and tons of oats to observe a health effect. It's just your daily bowl of oatmeal will really be able to effectively reduce cholesterol. So there's not that much research in the health effects about oat protein. We're still in preclinical trials. So we would really like to see if the oat protein is able to supplement the effects of beta glucan.
Okay, thank you. We have a question from Dr. Trust Beta. Is there an attempt to fractionate according to solubility and assess potency for each fraction?
See, that's a very good question. That's a little bit out of the scope of my research. I'm not assessing any sort of functional properties in the oat protein, but that would be a very good area of research to open up where we've been doing animal models and ELISA kits and Western blots. So that's a little bit out of my scope, but that's a very good question.
Okay. Maybe just one question about the animal model. Can you talk about the animal model that you used a little bit and how it's validated to for the disease condition that you're investigating?
Yes, so we wanted to induce metabolic syndrome and like high cholesterol in rats. So to do this, it's an obesity model. So with high fat and high sugar, unfortunately, you give them like, stuff like fatty liver, high cholesterol, and with this bad diet. So it's kind of reflective of, people that consume high calories, high cholesterol, high fat, and then markers of metabolic syndrome are like abdominal obesity, high cholesterol, high blood sugar, high blood pressure. So we have the control diet, which there is just a normal diet with casein just to compare. Then we have a high fat group with just the casein protein. And then the third group, we substituted out the protein source with oat protein. So we mainly want to compare whether oat protein has any effects towards these disease markers compared to casein.
Okay, thank you very much, Jenny.
Yeah.
Okay, our next speaker is Zhang Vem, and the title of his talk is Determining P amino acid content using near-infrared radiation spectroscopy.
Can I see my screen here?
Yes, we can.
Okay. I'll just start. Hello, everyone. My name is Songyang Wang. I'm a second-year master's student in Food and Human Nutritional Science Department, University of Manitoba. Today, I'd like to introduce my research program, determining the protein and amino acid content of peas using near-infrared radiation spectroscopy. Let's start with peas. As a leading producer, Canada has contributed about 30% to the global pea production in the past 10 years, which is higher than a combination of Russia and France. In domestic, over 99% of the production is attributed by Western Canada. Saskatchewan contributes over half of the production, and 42 of them are exported. The data listed here indicate that peas play a vital part in Canada. However, the existing measurement for the quality of peas mainly relies on the chemical analysis, which is high in cost, low in efficiency, and a range of sample available, or destroy the samples. These characteristics do not cope well with the large production. Therefore, this research aims at developing a method to measure the amino acid and protein content in peas using NIRS. Near-infrared radiation spectroscopy, or NIRS, is a non-destructive analytical method. By applying light to the sample and detect the level of reflectance, the NIRS can achieve the absorbance curve. The different combination of chemical bond and their ratio in a functional group in the materials makes components identical on spectrum data, like moisture content and protein. And this information can give researchers the composition of target sample from both qualitative and a quantitative aspect. The methodology of this research is classified into 4 stages. Stage 1, scanning a large amount of samples of pea seeds by using light of specific wavelength. Stage 2, carry out chemical analysis on randomized samples from 5 assays: moisture content, nitrogen content, sulfur amino acid, tryptophan, and the remaining amino acid. Stage 3, reach the statistic relation between the chemical data and the spectrum data from the previous 2 stages to create a calibration model. This model will be able to predict the composition of samples by simply scanning them. And finally, improve the model by considering the potential variation during the scanning, such as the morphology of the seed, duplicate, and so on. But how does this research relate with sustainable protein system in Manitoba? Actually, the potential benefit is more than we can imagine. And here, I've chosen 4 aspects to elaborate. First, pea is an excellent source of nutrition containing higher protein content and a well-balanced amino acid profile comparing with other pulses. Therefore, it is highly digestible. Comparing with animal source protein, pea contains high fiber, low fat content, meeting the dietary needs of the wider consumers, such as vegetarians. As the main ingredient of the Beyond Meat, it is foreseeable that nutritional value of peas is giving more potential to promote its marketing value and future possibilities. Increasing production of peas require advanced analytical method to ensure the quality. Since NIRS is a chemical and thermal free, it is safe for any technician to operate with little training. Samples of high value can be analyzed easily and safely without any loss. What's more, there will be no concern towards getting rid of chemical waste or pollution to the environment. These characteristics make NIRS highly compatible to large amount of analysis. Scanning of a single sample takes less than 30 seconds, making it highly efficient comparing with traditional analysis, which will take days to finish only 1 assay. So far, Manitoba only contributes about 4% to the total pea production in Western Canada, indicating a high potential for future development. And lastly, the plant of the peas benefits the agriculture industry from economic aspect. Study has indicated that spring wheat grown after peas require 8% less energy than after cereal. When a year of pea was included in a 4-year crop rotation cycle, the total energy requirement of the entire system can be reduced by another 13%. With numerous benefits described above, both peas and NIRS technology can pave the way for a long-lasting agriculture industry, not just in Manitoba, but also global-wide, and ultimately reaching a fully sustainable agriculture system for the future. Thank you so much for your attention. If you have any questions, please feel free to ask or send it to my email. Thank you.
Okay, thank you very much for the talk. And if there are any questions from the people listening in, please feel free to write them down in the chat box. One question I had was with respect to your calibration model, how many samples are required to test to develop a reliable calibration?
At this moment in my project, I have selected 339 samples to construct a calibration model, and this number will be furtherly extended to over 400. The number of sample chosen is based on population from different harvesting year. So currently I have sample from 2017, 2019, 2020, and later 2021. Previously, there are 2 similar programs from our group. focuses on soybeans and pulses and lentils. They use about 420 samples to finalize the model. So this will be the currently target I'm reaching. But there's no doubt that for more sample you are putting in, the higher accuracy and precision you will reach for the model.
Thank you. We have a question from Dr. Claudia Navarez. What controls will you use for your wet chemistry and for the NIR testing?
For the NIR testing, currently we have 3 control factors. So the first one is the duplicates. The first one is duplicates, and the second one is like the different from the first, we have chosen different times of the scanning. For example, for the same sample, we will scan it twice, but during each scanning, we will scan them twice, which makes like a 4 total scanning for a single sample. And also we're trying to put the morphology, like the wrinkleness and the color during the scanning. They do influence the reflectance and absorbance rate of the light during the scanning. And during the wet chemistry, so far we haven't put external factor control during the chemical analysis. We're mainly focused on the number of the sample and the different assay we're testing.
Okay. A question from Dr. Beta. 2 questions. 1, how many varieties are included in your model? And number 2, can you comment on the degree of variation among the various P types?
Thank you, Dr. Beta. I think the first question is similar to the previous one I've just answered. And for the variation among the P types, so far we have Ps from 4 harvesting years, 2017, 2019, 2020, and 2021. And these samples are breeded based on their morphology, like what's the relationship between their color and their protein content. So at this moment, I would say we have 2 main variations. The first one is harvesting year, which may be related with precipitation, temperature, and other environmental factors. And the second main category will be the morphology of the samples, which will be the color, wrinkleness. And yeah, that's the 2 main variations we're focusing among the P types.
For your calibration, once you do your calibration, is that calibration then moving forward only for that specific NIR instrument, or can that calibration package then be downloaded on other NIR instruments as well?
That's a good question. Actually, we are using more than one type of NIR equipment. Currently, we're trying to compare the difference between similar equipment, yet have different calculation method. But for the models that we finally reach, it can be downloaded and transferred to the other new equipment and use it to do the prediction for other samples. So it is totally shareable.
Okay, excellent. Thank you very much.
Thank you.
Okay, our next speaker is Savani Wikram S. Kara, a master's student. And the title of her talk is, what contribution does protein intake have on muscle mass and bone health in the context of obesity?
Thank you. Nice to meet you, everyone. My name is Savani, and yep, so I will be presenting on the contribution of dietary protein to obesity, to body composition and bone health in obesity. I will get Dr. Denson to share my PowerPoint. All right. Okay, so we'll move on to the next slide here. So as an introduction, so my name is Savani Wickramasekara. I grew up in Edmonton, where I completed a Bachelor of Science degree at the University of Alberta. Dr. Jensen, I'll just get you to get all the pictures up on there. Oh, looks like some of the pictures are missing. Oh.
That's all I have.
Oh, okay. Yeah, it looks like some of the images are not showing up there. Yeah.
That is okay. How would you like to go back? I guess would you like to go back to you controlling the slides, or is this sufficient?
Yeah, so some of the image seems like it's not populating here. So I think we'll just have to do what we can, and I'll just kind of talk, I guess, and we'll just kind of go from there.
Okay.
Okay, so this slide, basically, I got to improvise a little bit. So this slide is just an introduction about me. So I grew up in Edmonton, where I completed a Bachelor of Science degree at the University of Alberta. And then shortly after I graduated, I moved to Winnipeg, where I completed an after degree at University of Manitoba in Human Nutritional Sciences. So since then, I've completed my dietetic internship, and I'm now a master's student in the Food and Human Nutritional Science department, and I'm a practicing clinical and research dietitian. So aside, from holding a few different hats between being a student and a working professional, I'm also a mom to, 2 cats and a toddler. So my life's a little bit busy right now. Okay, we'll go to the next slide here. Okay, so this is just kind of a story or in terms of background in terms of my project. So, according to the Government of Canada, most Canadians consume enough dietary protein. The acceptable macronutrient distribution range states that one would need to eat about 10 to 35% of daily calories in protein. And a study that was done in 2016 found that Manitobans consume about 16% of daily calories in protein. And that in Canadian adults, protein intake was estimated to be around 79 grams. So, I'm sure most of us are aware of the staggering obesity characteristic or statistic where 1 in 3 Canadians adults have obesity, and they're mostly thought to require medical intervention to manage this disease. So I was curious to know, is 79 grams a day, does that represent the larger bodied individual too? And then on the flip side, chronic diseases such as diabetes, heart disease, metabolic syndrome, these are often associated with obesity, but what about our bones? The focus on bones seem to be geared more towards postmenopausal women and risk of osteoporosis, but not so much obesity. And so, when looking at, risk of osteoporosis and how to mitigate this, one of the recommendations for stronger bones is ensuring, the adequate consumption of protein. So these questions, in combination kind of prompted me to look at the impact of dietary protein and the contributions from plant and animal sources of protein that they have on muscle mass and bone health. And I would do this by assessing body composition and bone mineral density using dual energy X-ray absorptiometry. So go to the next slide here. So data from this project was taken from 2 clinical trials where individuals met the following inclusion criteria. So inclusion criteria at the screening visit, they had to be between 25 and 75 years old with a BMI greater than or equal to 30 kilograms per meter squared. Males had to have, certain fat mass greater than 23% and females greater than 32%. Some of their blood panels, so the fasting alanine aminotransferase, aspartate aminotransferase, LDL cholesterol, blood pressure, glycated hemoglobin, all had to be within the ranges accepted as healthy. And other chronic diseases were not confounding factors. So all the participants, other than having obesity, were generally healthy people. So at the pre-study visit, that's when we collected all the 3-day food records. So this is how I was able to calculate, the total protein in the diet and sort of separate the contributions of the plant and animal sources from these records. And then at the study visit, that's when we assessed body composition using dual energy X-ray absorptiometry. So going to the next slide here. So, so based on the 3-day food records, the average total protein intake was found to be 88 grams per day. So it was higher. And so that was average. There was also, the lower end and the higher end, which we'll talk a little bit about later. So the daily proportion of plant to animal protein was found to be 33% to 66% total protein. So a third to 2/3. And so when we're looking at the next slides, the total protein and protein from animal and plant sources were divided into tertiles here. So each tertile made up 1/3 of the low, medium, and high intake. And the data was analyzed using analysis of variance and Duncan's multiple range post hoc test. So we look at the first result here. So we can see that, obese individuals with higher total protein intake had greater skeletal BMD and lean muscle mass. Going to the next slide, we see the next result. So low, medium, or high intake of plant protein was found to have no effect on bone mineral density. However, a trend was identified for greater lean mass in obese individuals who consumed the highest amount of plant protein. And then the last result here, going to the next slide, yep. So obese individuals with high consumption of animal protein had greater BMD and lean mass. So going to the next slide, we conclude, and I had some great pictures for you guys. So I'm really disappointed that they didn't show, but we go to the next slide, so basically total protein or the mixed protein diet and animal protein affected lean mass and BMD, but not plant protein. And then the last slide here. So, basically, how does this all fit in Manitoba's protein ecosystem? So to start, as we identified earlier, it's important to know that people within this range, 25 to 75, are eating mixed diets with 1/3 plant protein and 2/3 animal protein. So that's good to know. So maybe it's not just about, animal protein versus plant protein or this competition between the types of protein, rather this understanding that there may be always a demand for animal protein, despite the potential for increasing demand for plant protein. So, the assumption that sustainable practices in both protein sources will be of interest to the public as our, increasing awareness of our current environmental health. So thank you very much. If you ever have any questions, I would be happy to answer.
Okay, thank you. Thank you very much, Sabini. Maybe I guess if I understood correctly, I guess one thing that you learned is the average Canadian. I guess in this group, these people are consuming more protein than is recommended. I guess maybe talking a little bit about some of the earlier speakers. I guess there is not only a quantity but also a quality of the protein. Do you think there's any interest in exploring? Can you comment on the quality of protein that the participants consumed, or how quality might play a role in your research?
For sure. So with going back to your question, so it's not necessarily they're consuming. So what I presented today doesn't necessarily say that they're consuming more than recommended amounts, rather within the range as identified to be, normal. And so if we're looking at calories from energy, it's within that range. As I go further into, my thesis analysis, I will be able to tell if it is greater than the 0.8 grams per kilogram, but that's not shown here today. So in terms of, quality, quantity, I do get this quite often. A lot of people have this assumption, that animal protein is higher quality in terms of, when you're comparing plant protein. And some, this comes from the idea that it's a whole protein and it has all of our essential amino acids. But, if we are eating a diet with, variety and we're having, different proteins in our day, that we are getting our recommended amounts of essential amino acids. And I don't, in my professional opinion, I don't think that is a concern if we are getting a variety in our diet. But I think that kind of fuels the notion of animal protein is better for us. Soy protein does, I believe, is more comparable because it is more complete in terms of amino acid profile. But yeah, I don't think that's more getting the variety in the daily.
Okay.
Yeah.
It was interesting to see that you use the DEXA machine. Can you comment on how you were able to determine using the DEXA machine about a higher amount of lean muscle mass, for example? How does that work?
Yeah, so basically the DEXA has a lot of functions. You can kind of isolate different areas in the body. It'll tell you certain components, upper like arms, legs, your trunk, the spine. So it basically does it all for me. And then we look at, the total lean mass that an individual has. And, we have a DEXA tech also who does all of the exams on the participants who helps out with that as well.
Okay.
Yeah, thank you.
We have a question from the audience from Dr. Claudia Navarez. Based on your results, what do you recommend to people that want to lose weight? How much protein, animal or plant-based, before or after exercise?
Okay, so if these people are, an athlete, they're exercising, their protein requirements would be generally higher than the 0.8 grams per kilogram. It really depends on how vigorous of, activity they're doing, but it is generally recommended to have, protein right after an exercise within the half an hour range to kind of optimize muscle protein synthesis. In terms of like animal and plant protein, it would really depend on the individual's preference, whether they, maybe they're vegetarian, maybe they prefer certain, kinds of proteins. But, I wouldn't generally say, have this protein is the best or not. It really depends on the individual. But protein recommendations for athletes can go up to 2.2, around the 2 range even. So it is very individualistic, but yes, there is a component of having protein after working out. Okay. To generally answer your question.
Okay. Thank you very much, Savani, for your presentation.
Thank you.
Okay, turning to our next speaker, Anashwar Valsalan, a master's student at the U of M. And the title of his talk is Understanding the Chemical Composition and Potentials of Underutilized Wheat Species, Einkorn, Emmer, Spelt, and Intermediate Wheatgrass.
Hello, good morning. Thanks for the introduction. My name is Anashwar Mullanpuri Valsalan. I know it's a long name. I have done my undergraduate in food process engineering, and I have 2 years of experience in product development in bakery. And I'm currently in first year of my master's in food science, and my supervisor is Dr. Manega Malalkoda, and we are into cereals research. Yeah, that is a topic, understanding the potential of underutilized wheat species, Einkorn, Emmer, Spelt, and intermediate wheatgrass. So what are underutilized grains? So you cannot find a formal definition for what they are. So these are basically grains which are in use for food or fodder, but in a limited levels. So there is lots of potential and are yet to be explored. So that is the main thing connected with underutilized grains. And this can be divided into 2 types, which are ancient wheat species, and then you have the perennial grains. Ancient wheat species mainly involves Einkorn, Emmer, and Spelt. Einkorn is considered as the mother of the wheat because it's the most ancient of all known cereals. And then you have Emmer. Emmer is very similar to oat species in terms of the weight, but it is tetraploid in nature. And the next one is a spelt. Spelt is almost similar to what we have in the common wheat species, and it is hexaploid in nature. So why are they called as ancient wheat species? Why not wheat? This is mainly because these grains have not changed throughout the centuries, whereas the common wheat has undergone lots of changes to meet the demands or meet the demands in terms of the yield. And that is a major reason why these grains have also fell out of favor. And these are actually making a comeback in this society, mainly because of the ecological benefits that are associated with it, because they do not require large amount of chemical fertilizers, or they have an extensive root system and even thrive in extreme weather conditions. And the next contender is our intermediate wheatgrass or Thinopyrum intermedium, or it's commonly called as the kernza. So these are perennial grains, so which can outlive the annual counterparts for 4 to 5 years, and they have an extensive root networks which provides all the ecological benefits which are associated with it. And the next thing is, like, in the nutritional perspective too, they have a very high dietary fiber in comparison with the common wheat species. So even if they have all these benefits, they have not been explored to its full potential, or only few of us actually know about these grains. Why so? This is mainly because that it cannot be compared with the gold standard wheat in terms of yield or the overall versatility of what wheat provides. So my research will be mainly concentrated on studying about the food science aspects and contribute my findings for the value addition for the commercial success of these grains. Objective. So we have planned for a 3-phase objective. The first one is about standardizing the milling. Milling is very important because each grain type differs in terms of their grain hardness, size, or the moisture level. So the first part is about standardizing the milling, or even do co-milling or floor blending with the conventional wheat species in order to get the whole grain flour. And the second stage, once we get the flour, is to identify the chemical composition of this flour. So we'll be doing a preliminary approximate analysis, and we'll be also conducting an STS page to identify the protein profile, because it's not just always about the quantity, right? And the next thing is that once the flour quality is being estimated, it is then combined with the water to form the dough, and the dough characteristics such as dough mixing time, water absorption, or gluten quality index, all those things are being investigated. And based on these results, it should be translated to the baking characteristics too, right? So we will be baking them to analyze the textural properties such as adhesiveness, cohesiveness, firmness, and we'll be estimating the total bread volume, and it will be compared with the common wheat species, and also a colorimetry analysis also will be done. So based on these findings, I'll be able to correlate how the physiochemical properties actually affect the functionality of the grain in the current food system. So why are we actually doing this? The main thing is that it's the benefits that are associated with these grain species in sustainable agriculture mainly. So the first one is related with the health. So here you can see that intermediate wheatgrass, or the perennial grain, has a higher percentage of dietary fiber in comparison with the common wheat which we have. And there is also the ancient wheat, which has a high percentage of antioxidant parameters or properties, which makes them superior in terms of at least these properties. Then you have the ecological benefits, where in this image you can see that the root length of the perennial wheat is around 15 times higher than, or more extensive than, the annual wheat species. And everyone knows about what are the benefits that are associated with an extensive root system, and how the soil is benefit out of it. And the other thing is that with how the ancient wheat species can counteract the climatic changes, mainly because these can thrive in extreme weather conditions, and they have been thriving for around 12,000 years. So that is another major importance or ecological services that are being offered by this underutilized grain. And then finally, economical values that are being created. These are mainly attributed by the health and the ecological benefits, because people are becoming more conscious about more health conscious, and dietary fiber plays a very important role. And the ancient grain market is also expanding. And the other thing is related with the perennial grain, because once you seed, you don't have to take care for the next 4 to 5 years regarding the seeding. So you're actually saving in that. At the same time, you're also saving in terms of the chemical fertilizers which are being used for the annual wheat varieties. So what are the restrictions, or what are the challenges? The one major challenge will be regarding the standardization, because almost all equipments have been standardized for the common wheat species. So there is a need for revamping. And the next thing is related with the flavor. So these grains have a nutty flavor, which is not common with the common wheat species. So it may not be appealing for the entire population. And the next thing is the safety aspects. Since these are from the ancient period, we have to identify the contaminants or the potential risk that is associated with the long-term consumption of these grains. And finally, product development. If a grain has to survive, in commercial terms, then there needs to be products developed out of it. So there is an increasing need for emphasizing the product development and the parameters associated with it. And that is it. Thank you.
Okay. Thank you very much for your talk. One question I have is with respect to the milling. You commented that you're optimizing the milling conditions. What milling conditions are you looking to optimize and vary?
One major thing will be regarding the tempering, and the other thing will be tempering is the major one. The second one is regarding the timings which are being given, and the clearance between the rollers. So and the other thing is regarding with the seed hardness. You cannot like mill it for a fixed period of time, because the seed hardness is comparatively like lower for underutilized grains when comparing with the common wheat species.
Okay. A question from the audience, from Dr. Navarez. Are you conducting sensory evaluation? If so, what type?
We have not yet planned for a sensory evaluation. I know the baking characteristics or the acceptability of a product cannot be confirmed until unless you are doing the sensory analysis. But we are actually looking forward to it. But for the time being, we haven't yet planned for a sensory evaluation.
Okay. Maybe just maybe another question from Ravinder.
Okay.
What is the protein content of these grains, and is there any information available about protein quality, amino acid score, PER, etc.?
Yeah. So regarding the protein content, in terms of just protein content alone, it is much higher than it's significantly higher than the common wheat varieties, like around like 15 to 18%, when the common wheat is having around like 12 to 14%. So then regarding with the like protein quality in terms of like protein digestibility, amino acid score, the research is yet to be conducted, and it has not been done previously, especially in terms of intermediate wheatgrass.
Okay. All right. Thank you very much, Anashwar, for your talk.
You're welcome.
Okay, our next speaker is Jai Chen, a master's student, and the title of her talk is Evaluating Trypsin Inhibitors in Legumes with an Improved Standard Method.
Hi, can you hear me?
I can. Maybe try speaking a little bit louder.
Okay. Hi everyone. My name is Jia Chen. I'm currently a master's student of food science. Sorry. Sorry for the mistake. I'm currently a master's student of food science under the supervision of Dr. James Harp at the University of Manitoba. First of all, I would like to introduce my research interest in my graduate study, which is different food processing methods affect the anti-nutritional factors, including trypsin inhibitors, lanthans, polyphenols, condensed tannin, and phytic acids, and affect the reactive and sulfur amino acids, as well as affect the in vitro protein quality without the use of bioacids for yellow peas and their related products. Legumes are rich in proteins, carbohydrates, dietary fibers, essential mineral and vitamins, as well as lower in fat. Legumes also contain the anti-nutritional factors, which are naturally occurring secondary metabolites produced by plants to protect itself from environmental stresses, such as pest attacks. However, the presence of anti-nutritional factors can lower nutritional values and reduce protein digestion, absorption, and quality. Therefore, compared to animal-based protein sources, legumes as a plant-based protein sources have a lower protein quality and lower utilization. So in this presentation, I will only focus on the importance of CYP inhibitors, and I will share a method for evaluating this content. CYP inhibitors are one of the most important and common anti-nutritional factors found in a variety of legumes, such as peas, chickpeas, soybean. And CYP inhibitors are a type of protease inhibitors and a class of anti-nutritional proteins. They have a negative impact of proteins by connecting with trypsin to form a trypsin inhibitors complexes, that is the indigestible complexes. We study in reduction of enzyme activity, the interference of protein digestion, decrease of animal bioavailability, and inducing pancreatic hypertrophy. However, CYP inhibitors are heat sensitive, so easily inactivated by food processing treatments, especially hydrothermal treatments. There are two official methods to measure the CYP inhibitors approved by AACC and AOCS. Both methods were adapted from Kagaday and co-workers. Those methods on the right side have contributed to develop the 2020 version of the AOCS standard methods. For the improved AOCS method BA12-2020 I use now, total acid volume changed from 10 ml to 5 ml with a high sensitivity and precision. This axis is an indirect measurement by inhibited trypsin activities, not directly measure the trypsin inhibitors, as using the buffer and trypsin to form a yellow color products. So we can have two tubes to find the difference of the absorbance between the presence and absence of the inhibitors. So, and then I can calculate the amount of trypsin inhibitors. So in my testing, the trypsin inhibitors of wall legumes have a higher variabilities when ranging from 4.53 to 58.73. Compared to wall soybeans, the trypsin inhibitors of the boiled soybeans was reduced by around 93% and by 91% in soybean protein isolates. So it's demonstrated the food processing treatment can cause a significant decrease in trypsin inhibitors. Other literatures also reported the trypsin inhibitors can even completely destroyed. Consistent to the trypsin inhibitors as a key anti-nutritional factors in plant-based protein source, this study provides an improved methods to measure the trypsin inhibitors for laboratories, and is expected to promote the development of the standard methods in various protein products. And this is my reference. And if you have any question and interested in these methods, please contact me via this email. Thank you.
Thank you, Jai, for the presentation. Again, if there are any questions from the audience, please please feel free to put that into the chat box. I think you show data from soybeans, if that's correct. Do you have what other ingredients, what other crops are you planning to investigate?
In my study, I was using the yellow peas and then to processing to pea protein concentrates and pea protein isolates. Also, the yellow pea will process to by different process treatments, boiling, autoclave, micronization, high pressure processing, and to make the meal seeds, to make a meal flowers, to so that is the samples I would use for the trypsin inhibitor measurements.
A question from Dr. Beta. Are there instances where trypsin inhibition is advantageous?
Yes, actually for the anti-nutritional factors, they have a beneficial and disadvantage effects on the human health and animals as well. So for the trypsin inhibitors, it would I saw one study say it would help for the prevent the chronic diseases, but it's just the initial study, so I'm not sure is it good for the human health. But so based on for the manufacturers, how they determine to processing the products without the trypsin inhibitors or with the trypsin inhibitor, or maybe they make a trypsin inhibitor substance for the product. I'm not sure, but they also they have a both effects. So based on their how they decisions.
Thank you. Any ideas of differences between protein concentrate and protein isolates in your analysis? Do you have a guess of what if there will be a difference?
Sorry, can you say again?
Are you testing protein concentrates and protein isolates for trypsin inhibition?
Oh yes, I use the pea protein isolates to test the trypsin inhibitors. It have a decrease to around 91% compared to the raw one. But I use a different varieties, so maybe they also have the same effect. So we can see the decrease after the processing. But I haven't tested the concentrate, but I will use this substance for my further thesis analysis.
Okay. Question from the audience from Ravinder. Are there any regulations regarding maximum amount of trypsin inhibitors content in the processed foods?
I'm not sure for this. I think no. Sorry, maybe I'm not sure this question. But based on house manufacturing to processing this substance. Yes.
Okay. Thank you very much, Jai Chen, for your presentation. And for the people in the audience, there will be a time to vote for the People's Choice Award, and that will continue. That will start soon and will continue to 12:05. And I think our system administrator